So with that being said, y'all make some noise for Ptah Dunbar.
Wow, I'm so elated. Thank y'all. Thank y'all for having me. I appreciate it. My name is Ptah Dunbar, originally from Atlanta, but I'm based out of Miami right now. And this is a talk about reliability as code. Brief moment that I was supposed to have my laptop right in front of me and doing a live demo, but unfortunately, we're gonna have a pre-recorded demo, do the demo part. But definitely reach out to me afterwards and I can definitely whip up my laptop and we'll talk about it. Hello, Wakanda. Wakanda forever. Everybody in here is beautiful. It's amazing to see all the front-end engineers that I've met over the past 2 days. This one included. Back-end developers and everyone in between. Y'all are doing amazing things and I'm looking forward to talking more with everyone to learn more how we can all add value to each other. I'm right here. Again, this is a talk about reliability as code. How do we move fast on stable infrastructure? That's the goal. We want to be able to have our product teams build applications and move fast while things are actually still functional and resilient. So that's kind of what we're reaching for here. A little bit more about me. I've been bridging communities and industry through various sources and just really helping gifted learners excel in technology. I call it STREAM. You have science, arts, you have arithmetic, reading, algorithms, math, engineering, of course, and technology. So I combine that all under a stream, and yeah, so I've been doing this for the past 15 years. It's been a lot of fun. This is my organization, Pirate School. But let's talk about the agenda here. So we're going to be talking about what is reliability as code exactly. We'll dive into incidences, outages, and fear, uncertainty, and doubt. The FUD, all the noise that's happening around your services. So we'll then explore a deep dive into the concepts. We'll do the recorded demo part, and we'll just recap at the end with any questions. Sounds like a plan? All right. Yeah. What is reliability as code? Well, we're taking all of the best practices around reliability and baking that into the source code itself. So that's everything from your unit test, your automated test, your ways of ensuring, that your systems are reliable. We're baking that all into the infrastructure, and also we need a way to observe that our software is actually performing as expected. So we'll want to set contracts with customers to those baseline performances of here's how my service is going to perform. So we call it service levels. You might have service level objectives broken down on your checkout process to make sure that checkout process is always up and functional. And so you bake all of these reliability best practices into the software itself, and that's what makes up reliability as code. It was funny, on my way here, I was traveling with my family from Miami to Atlanta, and I had to make the first choice between getting this $30 Starbucks order or making the flight. So that was number one. I decided to make the flight with everyone, and we boarded and we got checked in. And turns out the monitors, half the monitors on behind the seats were out. So the flight attendant got on the PA system and said, "Hey, the entertainment system for 50% of the seats are out. We need a way of fixing this. We can only do that in the air." We can only reboot the system, the entertainment system, in the air. So it seemed pretty safe. And meanwhile, I have my beautiful daughter here and entertaining the entire plane, saying that we're flying, this is her last flight, for free. So she was really excited. And so anyway, I have to wait 30 more minutes to wait for us to get up in the air. And they reboot the system. And it takes time. But every time the flight attendant kept getting on the PA system and saying, in 10 more minutes, the people whose monitors were working, actually, you have to remember where your bookmark was when you were watching your show or what have you, because when we reset it, you're gonna have to start all over again. So they were just informing us as they were recovering from this outage that, hey, you know, we're gonna get back online. But it took some time. You can't make this up. If we were to break this down under the people who know behind the scenes, like the team and your customers, it kind of looks like you discovered that something happened. Somebody's like, you know, you're going through your service and, you know, someone's clicking around and boom, a bug happens. And your system, your monitoring system or observability system detects that. So it's either or you're detecting an alert or you're discovering that there's a problem. And then from there, it's a matter of acknowledging it. And I shouldn't have clicked the slide, but you acknowledge it. You let everybody, you let your customers know, you let your end users know that, hey, the monitors are out, things aren't working, and we're on our path to resolving this error. I mean, from there, the pilot, they're gonna figure out, hey, this is the situation that we're in. They're gonna do a deep dive, retrospective of like, hey, we'll fix that in the future, but for right now, we gotta go in the air and reboot the entertainment system. And so that's then we're gonna be the next phase. Each of these phases take time. Finally, the recovery of rebooting back up the entertainment system, and now we have our entertainment with my daughter. She can watch her cartoons and enjoy everybody and leave them alone. This all takes time, and I'm sure your services have some duration of getting that mean time from detection to recovery. That's an important metric underneath reliability as code to be able to monitor and measure that if it's working or not. So MTTD and MTTR are key metrics and KPIs for you to look at to understand, are we improving in our quality, in our service, in our uptime, in our availability with our customers? Can we establish service level agreements with our customers to, you know, get larger clients and have them have some sense of, you know, ensuring that our services are quality and they're going to be always up and running? So that's what these KPIs are important to measure. Here's an example architecture of a team. You know, we got different languages that we're speaking in here. We got a front-end team, we got back-end team, we got cache systems. These are all these people are most likely distributed, you know, across the world. How many people here can sit with their team in one room? By a show of hands. We got about 20%, maybe 15. And so that means our teams are pretty big, and we may not always be able to communicate on a meeting. We have to sort of switch to an asynchronous flow. So how do all of these people ensure reliability, the database, the user system, the cart checkout? How can we ensure reliability across the board with all these different languages? Like, it's crazy. So some of the core disciplines that make up this practice, they start off at the infrastructure. We need to be able to describe our computer and the state of what needs to be installed and up and running for our developer engineering teams to do their work. You know, we need to be able to quickly spin up that environment and say, hey, you know, we can, you know, start adding new features and functionality, and we don't have to learn how to like plug everything up together. That experience should be very seamless. How do we do that? Well, we describe it as code. There's software called Pulumi. Another one is called Terraform, but the whole idea is that you're describing your infrastructure, the host, the computer, the memory, the resources that are required to serve your products and services. Next is containerization. You want to, you know, the world is moving to the cloud if we're not already there, and so from that perspective, the new applications that we're building ideally would be cloud native. So they take advantage of the properties of being serverless, being able to spin up and down very quickly. And so this is what that containerization is about. You want to ensure that your services and products and components can be containerized to be able to take advantage of cloud native architecture. What that looks like is Kubernetes. That's the de facto state of affairs. So I highly recommend diving deep if your assist sysops or engineer looking to ensure reliability with the infrastructure itself, this would be a great place to go to. From there, we have observability. Okay, we have our systems up and running. We have our applications up, they're running. But right now, they're black boxes and we have blind spots. We don't know the health of those services. We don't understand unless we log in manually via SSH or we poke around with it. But we shouldn't have to do that. So we need some type of way of monitoring and getting insights into those requests and response, understanding customer behavior, like all of that from outside the system. And so that's this observability concept. It's a new practice over the past year or so. It's been growing in popularity with open telemetry. But the idea is that you're capturing your logs, your stack traces, your errors, and all these like data elements, telemetry data, and you send it to a place where you can observe and improve on that software and that system. Service levels. This is where we're ensuring a contract with our customers saying that, hey, this service is going to be minimally acceptable up 7 days a week, 20 hours a day. Maybe there's a 4-hour maintenance period. That's your error budget there. So you need a way of defining, based off of the observable aspects of your system, hey, this is actually, this service is going to be up and running for the time that we said. We're not using opinions anymore. Everything is baked into code, so we're using data to inform our decision-making process. So you could definitely expand more. I know we talked about unit testing, integration testing, and there's other aspects to ensuring that our system can take advantage of cloud-native architecture, like embedding security within that loop for vulnerability scanning. But that's another talk. Some of the technologies that support this, again, that we saw was Pulumi, Kubernetes, and New Relic. Funny plug, I work at New Relic. Forgot to mention that in the beginning. I push code and profit at New Relic, and it's amazing. I talk to customers every day, developers and engineering managers, SRE, platform engineers, to ensure reliability and to add value to their architecture and their stack, and ultimately their lives. It's amazing. So this is the part where I whip out my laptop that's virtual and click to the next slide where I go through the demo. Let's see how good this looks. All right, we got some movement. Autobots. So because I don't have my laptop, we're not using Pulumi, we're using Terraform. I did this talk before for DockerCon, and so here's an example of a basic Terraform project. I could look right there. And so you describe your infrastructure through modules in this case. And so I'm going to deploy a sample, that microservices architecture that you saw earlier. I'm just going to describe my infrastructure there, and at some point you'll see code. If we could speed this up. There we go. So we can see that we're using dynamic variables so we can describe our API keys and things like that. And this module, sock shop, that's where our microservices architecture is defined. So right now I'm starting up a local cluster called Minikube, and that's basically on your right-hand side. You're gonna see the cluster turn online. And again, everything is gonna be written and baked into code. I just ran the Terraform init. That's the initial command that you would run to initialize the project. It's installing its dependencies. And then from there, I'll run Terraform apply dash force or something. I forgot what I did. There we go, auto approve. Because it's like, you really want to make this change, and looks like I got to run that one more time. Yeah, I didn't save the file. So it's initializing the dependencies that it caught, and now it's ready to apply. Boom. All right, so a new environment is coming online. This is super helpful for onboarding new developers, new team members. You don't have to reinvent the wheel. You can just, hey, here, it's up online, it's ready for you to start working and doing what you do best. So we can see that the sock shop application is initializing, it's broken it into different microservices, as we saw here. And again, modern teams aren't able to sit in one room. We saw less than 15% of the audience. They can barely, sit with their whole team in a room. Like, their teams are huge now. (2x) architecture. What is he doing? An example of the application that was launched. So it's an e-commerce store. And so this demo is actually a little bit longer because it's actually talking, I'm playing around with this technology called Litmus Chaos for chaos engineering on your, doing controlled experiments within production. So I'll also demo that within this talk. We probably need to cut it shorter because we have limited time. But it's really cool to, again, you're modeling the checkout flow, you're testing that things are working, and you can automate this. This was all done manually just to show that, hey, this is not scalable. And so there's this tool called Locus, which is a load testing technology written in Python to basically be able to instrument your services and test out that the core critical paths of the user journey is actually working. So that's what I install next. And I increase the replica count to 8. Yeah, because who wants to be testing their software manually? Like, we've solved this problem already. We're just baking this all into code, and we're ensuring that this is constantly, continuously running, so that way our systems are guaranteed to be online and functional and reliable. So next, after this, we're gonna install this software called Pixie. And Pixie is a protocol level tracing tool to be able to trace database calls, HTTP calls, just any protocol, and then basically provide observability around that information, around how long the latency it took from your services to go from throughout your network, from request to response. I think we're running it into some more. Yep, so there's Pixie, very nice. Pixie is hosting that telemetry data on the cluster itself up to the past 24 hours. So it's great that you own the data, but then you can't really work with it. We're in the same problem that we started off with, where they're still black boxes. So we'll use New Relic to basically send it to New Relic. That way we can visualize what our stack looks like. We can actually start making sense of it, and you don't have to be a coder to do it. It's super simple and intuitive. So that's kind of what the New Relic integration does with Pixie. And so that's actually, you can see that integration's up and running. What's next? I think I'm gonna define a workload and some service levels. So now that we have observability built in, we'll start adding service level agreements. So we'll verify that our checkout process is continuously at a certain performance level. So we'll ensure under 1 second, all of the pages are loading and they're fast and responsive. So again, as you can see, all of these best practices are combining to ensure more reliability throughout the entire stack. Very nice. So here I have a link that's gonna click over into New Relic once that gets loaded. And yeah, any questions so far as this is gonna go? Questions? Yeah, please. That's a perfect question. In a few more minutes, you're actually going to get your answer. Magically, I did this before. So yes, to your point, the question was, does New Relic, it provides observability, but it also provides the ability to describe your service levels across the board. And you can not only do that in the interface, you can also do that in code. How am I doing on time? Can I get a thumbs up or 1 minute? Oh, perfect. So here we have our golden signals across our entire stack, and we can, again, get visibility into what's the health of my services, my cluster, and this is all, you get that for free. So I don't have to design anything, move things around. It's using Google's SRE best practices around latency, up to, errors, saturation, to basically show you like how to reduce that mean time to recovery. That's the whole goal here. So we're all spending a lot of time, when an outage happens, like how do we get our systems back up online? Well, we establish service level agreements, we bake it into code, and that improves our reliability over time. Thank you so much. I'll post this on Twitter as well. Let's see if we'll keep going there. This is kind of a recap of what we just saw as far as using the different tools. And if anyone's interested, I'll also post the GitHub repo of the actual live demo for Pulumi. I like that better than Terraform. Any other questions? Thank y'all so much.